Good morning, ladies and gentlemen, friends and neighbors, boys and girls. Today we're going to have the polynomial functions video number 2. Okie dokie. And in this video, we're going to talk about the end behavior, and I will explain during the course of this video what in the world I'm speaking about when I talk about the end behavior of a polynomial function. So it's very important that we understand the degree of the polynomial and the leading coefficient. And we talked about this in the first video, video number 1, but it's worth reviewing. So here's my definition of a polynomial. I have a, b, c, d, and all real numbers. A does not equal 0, and n is any non-negative integer. So n we know is a whole number. And I have my polynomial f of x, a to the xn, plus b to the xn minus 1. And we know that this degree of this polynomial is n. So the degree is the highest exponent. That's the highest exponent, the highest power of x that you see. And that's the degree of the polynomial. A is the leading coefficient. A is simply the number in front of that highest power. So A is just the coefficient of the, it's just a real number, could be positive, could be negative. And my example here is f of x, 5x to the 6th. The degree here, we know already, we talked about that in first video of 6. The leading coefficient, we're just going to call it LC, is equal to 5. So in this case, the leading coefficient is positive, and the degree is an even number. We'll talk about the difference between odd and even degreed polynomials. And we look at g of x over here, and we know the degree here. The degree of g of x over here is 4. And the leading coefficient of this is -2, and this is a review. But very important nonetheless to talk about end behavior, I have to be able to recognize the degree and the leading coefficient. And before I start talking about the end behavior, I want to talk about this notion of this dude right here. That is an arrow. And it looks like an arrow, and it is an arrow. And if you were out driving your car and you saw an arrow would denote direction. So an arrow denotes direction. Tells you what direction to go. So don't forget that. If I had that arrow, I'm going to go up there. If I had this arrow right here, I'm going to go down and to the left. So just make sure that you understand and don't forget what the heck an arrow is. Alrighty? All right, let's jump into end behavior then. Alrighty? So here we go. Here are some very important properties of the polynomial function. The domain is all real numbers. This is going to be very important. The domain is all real numbers. And the graph is continuous for all x values. Continuous means that when I sketch the graph of a polynomial, I never have to lift my pencil up. The graph of a polynomial function is smooth. We'll talk more about that in pre-calculus. Smooth means there's no sharp corners. This is more of a pre-calculus topic. What we want to worry about today are polynomials are continuous. Dokie. And so here's the end behavior of the polynomial describes what the graph of the polynomial will look like towards the end of the graph. What do you mean, Mr. Strauss? I don't understand what you mean by the graph. Well, I'm going to go back here to this page here and explain what I mean by the end of the graph. If I go back here to a graph of something that I am familiar with. So I'm going to extend my page. I'm going to do the graph of this polynomial right here. looks like a quadratic, and in fact it is a quadratic. Let's let that be the quadratic x squared minus 3. And we know what the graph, if we remember about studying quadratic functions, quadratics are polynomials. Quadratics are a type of polynomial. This particular polynomial function, let me get that guy out of here, he's annoying as all get out. Okay, this, we know that this guy is concave up. Well, what I'm going to talk about today are the ends of this graph. I'm going to talk about the ends of this graph, both ends of this graph. Almost looks like a bug there. The ends of this quadratic. And I know, so what's going to happen here? What's happening with this end behavior? Well, it looks like it's going up. Well, what's happening is this. As my x values, as my x values get really big, as my x values go in the direction of positive infinity, that arrow means direction. As my x values approach positive infinity, as my x values go to the direction of positive infinity, what happens to the function values? What happens to the function values of that? Well, what's happening? They're going up. So they also are approaching positive infinity. And that's what I would say about this end behavior. As x goes to positive infinity, the outputs go to positive infinity. So the graph of this is going to end positive. It has to. It's never going to end, but the end behavior looks positive, so this guy here is going to end positive. The graph of that is going to end positive because the function value is going positive. Well, if I look over here at this other side, the left side over here, I don't know what that is. I can't get away from the face of that guy right there. But if I look over here, what's going on? Well, it looks like the function values are going, well, they're going up. We never go in the left direction. But what we're going to say here is that as x approaches negative infinity, i.e. as x goes that way, but we're going to write it as x approaches negative infinity, it means this arrow right here, x is going in the direction of negative infinity. What's happening to the function values? Well, again, the function values, the y values or function values, they're going up. The function values also are approaching positive infinity. And what we say is the graph starts positive because it's over here. It's starting positive. So it's starting, we know. It's decreasing, gets to its vertex, and it starts increasing. So these are the two statements. As x goes to negative infinity, f of x goes to positive infinity. That means the graph starts positive. And I have this statement over here. As x goes to positive infinity, the function values also go to positive infinity. And we say the graph ends positive. So that is just looking at this specific quadratic. And we're going to go back to our notes and we're going to make some generalizations about polynomials. And here you go. If the degree, we're going to do this guy right here. If the degree is odd and a is positive, i.e. if the degree is odd and the leading coefficient is positive, then the graph of the polynomial is going to start negative and end positive. Here's an example. So give me an example, Lee, of where the degree is odd and a is positive. Okay, let's go 5. Let me go 6 here. 6x to the 7th plus, you know what? When I talk about the end behavior, I don't really even care about the rest of the polynomial. It could do anything I want. It could be minus 2x to the 4th plus 3x. I don't care, because the only part I'm going to look at to determine the end behavior is the first term. And here, note, the degree is odd. 7 is odd. And 6, the leading coefficient, is positive. That's going to tell us what the end of that graph looks like. And I'm going to come over here right now, and I'm going to do a little sketch. And what the, let's see here. Starts, what does start? Oh, here's what starts negative means. That means it starts in the y negative, and it's going to end positive. Keep in mind, polynomials are continuous. So I can, and I'm not going to, but if I wanted to, I could do whatever I want on the inside. But all I'm concerned about is the blue, what's happening at the ends of the graph. Now, we'll make some determinations about the inside later on down the road, but keep in mind this is just about the end behaviors. Okay? So, and here are the two statements that I'm going to make. These are in part, this is what ends positive, starts negative, and what I'm going to say over here is, as x goes to positive infinity, what happens to the function values? F of x also goes to positive infinity. This is with right-hand end behavior. We're going to call this right-hand behavior. And what goes on over here? Well, I'm going to make the statement as x goes to negative infinity, because that's the direction x is going. Where do the function values go? The function values also go to negative infinity. And this is your left-hand end behavior. And that's what it means for a graph to start negative and then positive. Start negative and then positive. And here's your statements. As x goes to negative infinity, the function values go to negative infinity. As x goes to positive infinity, the function values go to positive infinity. Well, here's the only other option. If n is odd, a is going to be negative. So let's go for an example here, where n is, here's another function. We're going to call it g of x. I want a negative 3 x to the 4, or x to the 5th, because n has got to be odd. Plus, I don't really care what's on the inside. Doesn't really matter what the last term is. We'll say it's 1. And I'm going to do a picture of what this graph looks like. Oh, and what's happening? If n, so degree, yeah, degree 5 is odd. I've gotten this requirement. A, the leading coefficient, is negative 3, and it's less than 0. Then the graph of the graph is going to start positive and end negative. We don't care what goes on the inside, because we're only talking about the end behavior. And this is the part. Let me erase that blue. I want that in yellow, because I really only want you to concentrate on the blue part. That's what starts positive and ends negative is all about. And we're going to make two statements. So we're going to make this statement here again. And what's going on? Well, as x goes to positive infinity, what's happening to the function values? The function values are going to negative infinity. This is your right-hand behavior. And I can make this statement over here. As x goes to negative infinity, where do the function values go? Bam, positive infinity. So if the degree is odd, if the degree of your polynomial is odd, the graph is going to start negative and then positive, or start positive and then negative. and it's all dependent on that very first term. All dependent on the first term of your polynomial. Let's go if the degree is even. Here you go, if n is even and a is positive. Here's an example. Should be kind of getting the idea right now. I want a positive, so let's go 3 x to the 6th plus, we don't care because we're only going to look at the very first term. We only look at the first term, we don't care here. And what does the definition, what does the theorem tell us? That if n is even and a is, the graph is going to start positive and end positive. And actually, we saw one earlier on that very first example. Oh, let me get that guy out of there, Dad, burn it. So here you go. We only care about the ends. It's going to start positive and end positive. We don't care what happens. All we know, something's going to happen on the inside because it is continuous, and it is going, I'm going to be able to sketch the graph in one sweep. But if I'm talking about end behavior, I only worry about the ends. And if n is even, here I have 6 is even. 6 even. 3 is greater than 0. It's going to start positive and end positive. Let's make a couple statements over here. What do we know? As x goes to positive infinity, the function values go to positive infinity. I'm going to tell you what, Red, this arrow concept, calculus is based in this arrow concept. So it's very, 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 very important for you to wrap your head around this arrow, this direction. The direction that x is going, the direction that the outputs are going, the f of x's. And what can I say over here in this direction? Left-hand end behavior as x goes to negative infinity. X goes this direction. People get confused. What do you mean? That means as x goes to negative infinity, what's happened to the function values? The function values are going to positive infinity. That's what it means to start positive and end positive. I'm starting my graph over here at positive. What? What? And end positive. Start positive and end positive. That happens if the degree is even and the leading coefficient is positive. And then the final, there's only one other option here. And the final option is negative 4 x to the 6 plus, we don't care. Another x to the 6. Didn't have to have an x to the 6, but that's okay. What's going to happen? The graph of the polynomial starts negative and ends. What does start negative? What's that? Oh, here's what it means. It means that the graph is going to start negative and ends negative. How can that happen? Well, it happens if n is even, home skillet, and if a is less than 0. So we're going to do something on the inside, doesn't care. And I'm going to make my two statements. As x goes to positive infinity, the function values, where do they go, Lucy? You bet they go to negative infinity. Make my statement over here. As x goes to negative infinity, my function values also go to negative infinity. And that's what it means to start a negative and end negative. Okay? And then the final parts of your, you can pause the video at any time. That's what's nice about videos. Pause the video. Okay? Get your good notes down. The last thing in this video, I only have like 1-2 minutes left. If I go back here, a power function of a polynomial of n degree, where a, b, c, and e are real numbers. Here's our power functions. Oh, power functions have one term. One and only one term. Because it's the powerful term in the polynomial. Every polynomial function has its own power function associated to it. So if I have this polynomial right here, home skillet, what's its power function? 5x to the 6th. That's the first term. That's the power term. One term, the power term. It's what they call power term. Guess what, ladies and gentlemen? The power function, the polynomial's power function, is going to behave like the polynomial. Where? At the end. So the power function is going to determine the end behavior of the polynomial, and that's what all of my notes were about previously. So a polynomial's end behavior is determined by its power function. That's why if I go back to the previous page, what did I worry about? I only worried about power function. Come on, dude. Power function. Power function. Power function. Power function. So power functions are easy. Hope you got these notes on the end behavior. I'll zoom out so you can, if you want to, look at all the notes. And I'm going to end the video. I will see you soon. I'll catch